There you go, Cam.
And screen sharing has been enabled.
Okay, so we have one last thing. We have on our screen, we have a big meeting is being recorded thing, and somebody needs to click, got it.
What could possibly go wrong? Okay. Let's see here. We're talking robot news. And I've got something else here. I posted in the mailing list. Can you hear me okay?
Yes.
Yeah.
We can hear you.
All right, I'll put this in the chat. And that's news about robust AI. It looks like they're in the warehousing space. They've come out with two products, Grace and Carter. Grace is software, and it's all very human-centered design, no manipulators, no LiDAR, 16 cameras. Some of the interesting stuff is you don't drive it around, it follows you around. And they have like the handlebar where you touch the handlebar and you're moving it around, you know, instead of guiding it with a joystick or it being completely autonomous. What they've really done is looked at the small warehouses and see how they work. And they're designed for like not the 50,000, I don't know anything about warehouses, but 50,000 foot square. They're not designed for that. They're designed for the 10,000 foot warehouse, you know, or small manufacturing to fit into their normal workflow. So you've got the handle that you can move it around. It'll follow you around and create the map, and then you can label the rooms and stuff like that. So that's robust AI. You know, it's like selling one robot at a time versus, you know, these big companies that, you know, if you're not buying 100 robots, they don't want anything to do with it. And their software, Grace, potentially might work with other than just their own robot Carter. So that's local news there in Silicon Valley. Robust AI.
So if I can just add a comment there, Camp.
Of course, Dave.
And that is that if you go and watch the video of Carter moving around, that should count as Shiloh's robot demo for the night.
All right, one of our own, longtime homebrew member, Shiloh Curtis. I think she started in the club when she was like 10 years old or something, right? She always would whip,
7, I think.
she would always whip us in the table block challenge. Good times. What else? Robot news.
I'm posting a few in the chat, Cam.
Give us one highlight, Thomas.
Oh, you want me to run it from my machine then?
Yeah.
Sure. Hold on. Give me a second. Share screen. Optimize for video. Go. Okay, oh, there we go. It froze up there for a second. So this is out in Tokyo. They were having their Robot Exposition earlier this year.
Your screen's not showing, Tom.
It's not showing.
Shows for me.
Yeah, I'm seeing it too.
Got it.
We can see it.
I see
Okay, maybe
it.
just a second.
It's stuck.
All right, well-
Yes, that I agree with.
I'm starting it
I
again.
can see it.
Starting it now.
Looks good.
Oh dear.
Yeah. Is that a deer or is that a lion? I don't know what it is. Ibex, maybe?
You gotta love the Japanese.
Why build a horse when you can build one of these?
All right, that's cool. We need to move along, Thomas.
Yeah, sure.
Any other robot news out there? All right, moving right along, club news. Club news. Ralph, you out there?
Hey, how you doing? This Ralph or a different Ralph?
Ralph Hicks.
Which
ladies
Ralph we're
and
talking
gentlemen.
about? There's like 6 Ralphs in the club, right? And it is a robotics club
This
after
is the hip Ralph.
all. Sorry, you were asking me a question. I missed that. Did you want to Robotnik maybe?
Yeah,
Yeah. Oh, very good. Well, so far 3 people have signed up. It's still on. We have the place booked. It's ready to go. We were solid on that. Last time, maybe 5 or 6 people signed up, and then 50 people showed the day of the event. So I'm sort of hoping we do something like that this time. But would like to encourage everybody to, if they're thinking about going, just go ahead and sign up. And again, the main event will be Robo Magellan, but there's plenty of open space back by where the picnic tables are. If you want to do like a a NASA retrieval rover sort of a challenge, test yourself on that. Plenty of room for doing that kind of thing too. So, either way. So anyway, yeah, I'd love to see everybody come out. We had a great time, whatever it was, 3 years ago when we did this last time. And it was a blast, and there was geeks and robots and all kinds of fun stuff and food and barbecue. It was a blast. So hopefully some people can make it and we'll have a good time. I'll be
so
there.
this is September the 10th.
Yes, Saturday, September 10th, correct, yes. Yeah.
Okay, and I think you said you were going to be there at 8 a.m., but what time should folks show up?
I'm gonna get there early just because I want to make sure we map out that space in the field and get that snagged, before anybody else grabs it. So, you can show up whenever you want after that.
What do we say, 10 a.m.?
Sure, that'd be good. Then, they will kind
Right,
of.
September 10, Botnick. What's the name of the park in Sunnyvale?
Baylands.
Bayland Park.
Yeah.
Very
and
nice.
Check the links in the Google group alias for the Botnick update, but it has the PDF and all the links and stuff, but it's at Baylands Park. Yeah. And
Ralph Hicks, ladies and gentlemen.
yeah, this should be fun.
Thank you very much.
Yep.
All right, Thomas, you want to talk about the Verbal Intelligence Group?
Sure. For those of you who've been living under a rock, a few members of the club started a spin-off, but we don't call it a SIG because we can't call it a SIG because this is the SIG. So
No, this isn't the SIG. This is the general meeting. Get it right, Thomas.
oh, I'll never get it right. All right. So we started a spin-off group called the Verbal AI Group. See, I can remember it now. What we do is we're talking about verbal input, verbal output, and basically the communication that happens inside of it. And we're running the whole gamut of artificial intelligence. And we have a lot of people with a lot of ideas. And we meet tomorrow night at 7 o'clock.
Pacific time.
Pacific time, yes, 7, 8, 9, 10 p.m.
Don't confuse people, Thomas.
Right, 7 p.m. Pacific time. And just FYI, starting the following month, we're going to change the date. We'll let you know, but it's tomorrow night. Be there.
All right, Thomas, thank you very much. What else in club news? All right, I got one more thing.
Hang on. I am having a harder and harder time making it to these meetings. So we're going to probably at the next business meeting have to find somebody else to MC the meetings locally here. So I just wanted to let people know that that's coming down the pike here. Okay.
Thank you very much, Wayne.
Thank you.
Wayne Gramlich, our forever fearless leader. Next month, September, is our 20th annual HPRC Challenge Phase 3. And so, yeah, this is 20 years. And we do 3 of these a year. So this will be our 60th challenge meeting. And so the concept is you are responsible for the presentation next month. You, as a member of the Homebrew Robotics Club, should be building a robot. And so next month, we expect at least a 5-minute demo showing us your robot or your work in progress. Our stock in trade is functioning robots, but works in progress are good for partial credit. So next month is going to be the HPRC Challenge Phase 3 again. And everybody knows the mailing list. Everybody knows our homepage. There's a link to the challenges there. And there's always Run What You Brung, which is the original Homebrew Robotics Club build. That is building the robot that you want to build. Any more club news out there? Oh, I'm going to throw something in the chat here again, because I picked up and I put a link in the mailing list. Factory refreshed Nito robots, they're $90. And I got one and it's refurbished, it's clean, it works. And consider the source, but I consider the bot vac the best way to learn ROS. There's my GitHub with the bot vac package originally created by Michael Ferguson and worked on by Ralph Ganock and a lot of the SV robotics folks, Alan Fetterman, and the Python 2 was taken up to Python 3 by James Nugent. So this is a homebrewed effort, but again, I see these $90 refurbished and I had to buy it myself, and it really, it's good. So, okay, any more club news? All right, now what I need help with, somebody need help with something specific. James, you're not going to mention the PyCam and the lid camera?
No, I'm not. I'm going to talk about this weird thing with Raspberry Pi where you can get to Google, but you can't get to GitHub.
I solved that problem.
You solved it. Okay.
I solved it. Yeah, thanks for all you guys for helping me out last night. The way I was able to get to it is I had to go through Chromium, log on to the GitHub site with my username, password, and two-factor authentication, and then I was able to ping it and get cloned the whatever. So I was able to go on to the next step until I got a different and unique error code, which I put in the mailing list just before the meeting. So you had to be logged into GitHub for it to work.
So you had to log in with Chromium before you could go in with your Pi?
Yeah.
Interesting. Okay, well, that was a whole thing Tuesday night, wasn't it? Last night?
Yeah.
Took all Tuesday night.
Any other what I need help with? All right. So show and tell. Who's got a show and tell? Oh, don't tempt me.
So Camp, we have an interesting thing here. Nobody brought a robot to the on-site thing. We are most embarrassed.
Come on, guys, got to get together now. We can change that next week.
Thomas has got something he's holding up.
Go for it,
Oh, I
Thomas.
love those evil little guys.
So this is a popcorn holder from Disneyland. They made them to look like the mouse droids. I think half or 1/3 scale. I don't remember. And I'm turning it into a mouse droid. As you can see, I've got a ping sensor on the front. And while this meeting is going on, I'm adding these two little speakers on the back. It's going to run via Raspberry Pi. Oh, I've already got the Pi in there. And
Very cool.
What's that?
Very cool.
Oh, very cool. Yeah. And it's got the Adafruit music maker. These are wonderful. These work out of the box with very little futzing around. I got it working in about 15 minutes, as opposed to one of the other ones that I still can't get working, some other brand. But these Adafruits, they're about $35, and you can play, hundreds of sounds from it and get it triggered by any microcontroller. But they're meant for the Arduino. They just plug right in, like as a shield, I guess. And I had to make some modifications of the wheels. I just put 2 continuous turning servos on the bottom and modified the servo horn to go right over the wheel, and it works. The software is almost there. Hopefully, maybe by the next meeting, we can have a running mouse droid.
Isn't that part of the empire? They like spying robots.
Yeah, the Empire. Yeah, they love their robots, don't they?
All right, what else? Any more demos? I'm trying to put one together here at the last minute, but it's not working too well.
I got another one, camp after yours.
You go.
Okay, I got to reach around the back of the computer here. Let's put it out of camera. So I'm doing animatronic robots, and because I don't know the ins and outs of these motors so well, they're high-end servos. I don't know how many amperes they take in the whole 9 yards. I put together this emulator here. And so I think I showed this last time. I don't remember. I belong to 3 clubs. I can never remember which clubs I showed what at. So this thing has 1, 2, 3, and 5 is 5 degrees of freedom on each arm. I attach this hand to this one, and each one of these has a different servo for each finger. The good upside of this, I just purchased it whole. These things go for about $100 or so. The downside is I have to move the thumb. The thumb is good for a thumbs up, but it can't grasp anything. On the other side, I've been working with more humanoid animatronics, and I have this rubber glove that emulates, that was made from a human hand. Underneath it, I have a servo that's attached to 2 fingers from a mannequin. I could probably get that working here. Let me just hook it up directly, and we'll put it on a servo tester, and I'll show you that. Can you see the hand all right, or should I move it closer?
It's okay.
I forgot about this meeting. Otherwise, I would have had this thing hooked up. I took it apart again. I keep taking it apart and putting it back together. So one of the downsides of this glove here, I'm going to turn it sideways so you can see it better, is it was cast this way. And to grasp something, you have to cast it like we normally hang our hands with, like a U shape between the thumb and the pointer. So it's a little bit awkward, and it's funny shaped. So I'm going to try casting my own eventually. But right now, I was trying it out with just 1 servo motor to see if I could grasp, bottles and cans and stuff. And I'm just moving the thumb, and that seems like it might be enough to grasp some things.
That's not creepy at all, Thomas.
Yeah, well, I live in the uncanny valley. We have the group here lives in the Silicon Valley. I live in the uncanny valley.
All right. All right, very fine. Thomas Messerschmidt, thank you very much. I'm going to get a quick demo in here before I tried my others. I can't do the full stack, so I'm going to just do part of the stack. This will be Floorbot. Floorbot. This will be Floorbot Challenge Phase 1. I'm doing wave following mode here in nav 2, ROS 2, and this is the bot back package. I've actually got the camera and the ultrasonics on top of there, but they're not running right now. Let's see how this goes.
I'm seeing Thomas's.
Yeah, I'm trying to unspotlight Thomas and get a shot of the robot, which seems to have locked up a bit. So everything's, oh, I see. Boom. There we go. And
Now you got it.
boom. There's the,
I'm back.
yeah, I see you back. Get my finger right here.
You just can't get rid of that gal.
Yeah, what can you do? Back to the, yeah, okay. He seems to be stuck. I'm gonna give him a hand with teleout keyboard.
You mute Thomas, he won't keep popping up.
See if he goes back to navigating. You got a little delocalized there, but he's back. What'd you say, James?
Thomas keeps popping up. If you mute him, then that won't happen.
Okay.
Myself. Let me mute myself.
Yeah, my robot's crashed. That isn't bad.
He was doing so good until just the very end of the hall there.
But he's not. Oh, wait, he's recovering. Here he comes back. Let's see if he can make it back. I gave him a new day. Oh, he's totally delocalized. It's actually kind of exciting because I like to reset the pose. The pose is right here. He thinks he's over there in another hallway. Oops. Well, anyways, this demo's going totally right. My robot has disappeared. See, I could drive him up though. No, he's going further into the other room. Okay, this one's totally screwed up. So let me turn off the screen. And any more show and tell? All right. My robot is taken off into the other room. Okay, so without any further ado, I'd like to introduce our presenter this evening out of Chicago, Scott Monaghan. He's going to show us his a companion robot, RoBud. So Thomas Monaghan, go ahead.
Thank you very much, Cam. Thank you very much. Am I spotlighted right now? I'm connected with two things, one for audio and one that says Scott M presentation, and the presentation one should be spotlighted.
Bear with me.
That's it.
Oopsie. Are you spotlighted? Did somebody beat me to it? I see. Okay.
I think so. Okay, thank you all very much. All right. Well, I want to thank everybody at the Homebrew Robotics Club for letting me present this today. This is really exciting, especially Stephen for reaching out to me and asking me to do it. So this presentation is called Building RoBud, Lessons Learned Building a Hobby Companion Bot from Scratch. Let me just kind of go over what I hope to, what this presentation is and what it is, and set the scope of the presentation. So the idea here is to give a brief introductions to the solutions I chose for the common robotics challenges that I think other people might run into, and hopefully get something out of it. And for each of these challenges, I'll define the challenge, I'll go over the chosen solution and why I chose it. If I can, if it makes sense for the thing, I'll give a brief demo of it. And I'll always provide links to further information and then RoBud's related code that has to, that actually how I implemented that. This presentation is not a deep dive into the RoBud project. It's an ongoing project, and I really wanted to make this hopefully useful for other people who are trying to just solve these same problems. It's not a detailed tutorial for the implementation of any of these technologies. We just don't have time for that, and I really wanted to point folks in the right direction. It's not necessarily a full-throated endorsement of any of the solutions that I use here. I know, I'm sure as other people in homebrew robotics know, it's you find something until it works the way you want it to. And if it works right for you, that's the solution you're going to use. That said, all of the solutions that that I'm be showing here are the software at least is open source, and it would work on Raspberry Pi or Jetson Nano or any Ubuntu or Debian based Linux system. I'm not going to be covering 3D printing or 3D design in this. That's well covered elsewhere. And again, I just realized I originally was going to talk a bit about it, but I just cut it for time. And then lastly, another thing I'm not going to cover, which I am interested in chatting with, afterwards or anytime or over email, is choosing the Jetson versus the Raspberry Pi. Originally with RoBud, I was using Raspberry Pi. I switched over to a Jetson to be able to do some more computer vision on a $99 board. But because of the craziness with the chip shortage right now, all the decisions that I made back then don't really fit right now, and hopefully they won't fit. The situation right now with the chip shortage will end within like the next 9 months, and Raspberry Pi and Jetson Nanos will fall back down to regular availability. So I'm not going to go over more than I just said. Here's what we'll be covering. So I'll do a quick introduction. I'm going to talk about my decision of whether or not to use RAWs. The technologies that I'm going to go over are how I achieved a publish subscribe model that was sort of roll your own, how to do animated displays and keyboard control pretty easily, the stack that I use to make RoBud hear and understand, the stack that I use to make RoBud speak. And I had a lot of trouble with power. So I wanted to share the solution that I finally landed on for power because I really love it and it works great for me. So to get started, introduction to RoBud and me. So RoBud. The idea of the RoBud project is I wanted to make a robot that was lovable, accessible, and autonomous. It's a companion robot. It is designed it's really just to exist for fun. When I just try to describe the goal to folks is to have a lovable robot that is sort of a cross between a puppy and a 2-year-old. And just, wanders around your house, makes connections with people, and is a lot of fun to have. That's the lovable part. And the accessible part that was really important to me for the project was I had gotten some social robots. There's the Gazebo and there's the Anki Vector, and they were really cool, amazing bots, but they all had connections back to their company server. They required the companies, they weren't standalone. It's really hard for them to exist on their own. And what happened is for the social bots, there's just not a market big enough yet to be able to cover the cost of a big commercial company producing these things. So you see these companies produce these amazing little bots, and then they go out of business a year or 6 months later, and it's really sad. So what I wanted to do was build a bot that really, that does the same thing that the Anki Vector did, but it's something that you can build yourself with parts that are readily available, using all open source software, following step by step without too much difficulty, with a hope that eventually, other people will be interested in this project and it will continue on and build a community around it of people who want to build this. So that's the idea there. I've been working on it since April 2021. And right now, as I said, it's based off the Jetson Nano single board computer. And all of the code.
Scott,
go ahead.
Can you tell us a little bit about yourself, where you came from to get to here?
Oh, sure. I'd be happy to do. You might want to hear a little bit about Scott Monaghan. So I live in Chicago with my wife and my 10-year-old. For my day job, I've been working for more than 25 years professionally in software coding and as product owner and software maintenance. That's my day job, still is. And I've been about 10 years ago, I got myself an Arduino, got the Blink code going, and I've been hooked on it since. I have about 2 years in homebrew robotics. RoBud is my second robot. My first robot was a robot named Alice that used an Xbox Connect to translate your body motions to the robot so that you could kind of embody the robot like an avatar. And that was a lot of fun to build, but it was my first attempt. And that project I sort of put on hold when I started RoBud. And here's my Twitter and GitHub information if you want to see stuff. And also, if you want to see more of RoBud, I've got a whole bunch of RoBud videos on TikTok that are kind of fun at tiktok.com/ScottsRobots. Does that answer your question?
Yes. Why have you thought about publishing on YouTube?
I have, and I publish on YouTube as well. One of the reasons that I actually have a lot of experience from early days of YouTube, and regularly publishing on YouTube just it takes a lot of time and production value, whereas TikTok videos can take 5 or 10 minutes, and that's really the difference. Once a RoBud gets to a point that I'm ready to share with sort of general availability on it, I will probably want to do more to promote it, but it's very much in a, build on my own right now. And I also have a friend who is, just started their attempt to build it to see how it goes for a second person. But that's...
You could publish just this particular PowerPoint on YouTube.
Oh, yeah. Well, I think Homebrew Robotics will do that. So I know that you guys do post these things. So
We have a meeting archive page, and if Scott will give us the slide deck, we'll put a link there in the HBRC meetings archives page.
Yep. Yeah, I'm happy to do that. I'll send it out to the mailing list, and I also put the slide deck, if you slide up in the chat window at the beginning of the meeting, I put the link to the slide deck there. And I'll do, if for some reason that got cut off for anyone, I'll put it in after we finish the presentation here. But enough about me, enough about the basics of RoBud. Let's talk about some real heavy stuff. And this is to ROS or not to ROS. That is the question. So let's talk about ROS. What is ROS? So ROS stands for Robot Operating System. And again, it's pronounced ROS. When I first started working with it, I was calling everything ROS. But guys like Camp, they know how to pronounce it correctly. And I think Camp, you might have made a couple jokes about it a couple times. So, if you want to be with the cool kids, like the folks who work with it, you say ROS. It's one thing it's important to note that's like if you're not familiar with it, it's not actually an operating system. It's a middleware that is installed. It's a middleware that runs as a service on your bot or in your bot's ecosystem that provides a standard for disparate robotic modules to communicate and coordinate with each other. At its heart is a message handler that the different nodes of your robot can send messages to this message handler, whether that's sensor data coming in or it's teleoperation or whatever. The message handler then nodes can also subscribe to get any messages. And what it allows you to do is have really discrete nodes of your robot that are all separate from each other. They can even be programmed in different languages. You could have stuff that's in Python, stuff that's in C++. And as long as it can publish to the ROS core, it allows all the things to work together. And that's a really cool thing about ROS. And if you want to learn more about ROS, I've got a couple great places you can go. You can start and go to ros.org. It is the place where the folks who actually work on ROS will give you the whole spiel about what ROS is and how what you can do with it. But and maybe even better, the HBRC ROS SIG every Tuesday night with our own Camp PV, where you'll get Camp will be working on ROS, and everybody will talk about the problems they're having, the new things that they've discovered, and it's a cool meeting to join.
One question.
Yeah, go for it.
Are you running Ubuntu on your Jetson Nano?
Well, let's talk about that. You're getting a little bit ahead, and I'm going to cover that. So hold that thought, okay? But I am not. So I'll tell you that I'm not. So here, let's talk about some pros and cons of ROS from my perspective. So as a pro of ROS, it's really become the international standard for robot research. So if you see anything that comes out of like an academic institution about any new robotics research that's been published, chances are that as part of that, ROS was used. It's really great at being able have it. It's got its built-in nav stack, and if you have a 360 2D LiDAR on your bot that is, popped right in the middle of the thing on its head. ROS was originally designed around that as far as its nav stack, and you can implement pretty amazing SLAM using ROS. And if you look at what Cam was just showing, what Camp was just showing earlier, that was his Nito bot vac.
That was a poor demonstration, but go ahead.
It wasn't a poor demonstration. I mean, what it did is, I think it really showed I think it's good that it didn't work, because it also shows the challenges. And that's the thing about ROS, it's not plug and play. However, the software that Camp was showing, it's called Viz, and that it had a whole map of his house that was mapped out by the LiDAR, and then the robot was trying to simultaneously localize and map and figure out where it was. That all, Camp, if you had to build all that from scratch, it would be almost impossible, right? I mean, there's different ways to do it, but ROS really gets you, a lot of the way there. But it's still work. Another awesome thing about ROS is you can simulate your robot in its entirety in a program called Gazebo, and your robot ROS won't even know it's not in the real world. You could simulate part of your bot in Gazebo and have part of your bot in the real world too. And I've seen some things where, especially again for like large institutions, they'll have bots that they want to be able to navigate a messy office. I saw this bot, and the bot itself, was over $200,000 in components. And the thing that they wanted to do was to be able to move around without crashing into things. I mean, you're first starting that out and doing the research. You don't want your $200,000 robot smashing into stuff. And it's big too. You also don't want people getting hurt. So if you're working with something that's large or that is really expensive and you don't want it to break or hurt anybody, you can build the whole thing in simulation at a really, really minuscule level, and be able to do the simulation first and then bring it into the real world. And I don't know anything else that can do that. Another great thing about ROS is it's got a passionate community of folks who are working at it, especially at the amateur level. And then it's you can get ROS all set up and out of the box on several starter platforms, which you can then build off of. So you can get it on the TurtleBot 3, iRobot Create 3 uses it. Camp just went over the Nito BotFac doesn't come with it out of the box, but there's folks who have put together a whole ROS package for the Nito BotFac that allow you to really jump right in and start building on top. And then also there's a Jetson based bot that someone in our group I know showed off called the Nanosaurus. And that also has, ROS built in. And if you can work with something with ROS built in to start, if that's what you want to do, it's a great choice because then you can build on top of it easily. Oh, another one, of course, is the Lino robot that has ROS built in. All right, so let's talk about cons. And there's one giant con for me. It's hard. ROS is not something that you think you just download and go and you're ready to you're off to the races. It's a very deep, it's a topic that goes very deep, and the learning curve to really get moving on it is high.
It's not a learning curve, it's a learning cliff.
Yes, yeah, and the thing is though, like if you're into that, it's I would put it
It's a
in like,
learning wall.
Yeah, it's like learning Unix or Linux the first time, and it's similar level of depth. It's not something you can just jump into. It has, and this is what the question was, it has, if you want to install ROS, it has a specific OS requirement. So if you're working with a Raspberry Pi or a Jetson like me, that means that if you're wanting to install it natively, you essentially have to blow away the operating system for your single board computer and turn it into a generic Ubuntu Linux machine. And you can certainly do that, but then all of a sudden, all of that community around the Raspberry Pi that does stuff that's specific for Raspberry Pi. Hey, I've got some loud noise coming in the background, crunching. Can someone mute? That's better. Thank you. So again, you lose the community of the Raspberry Pi and all the things that work specifically for that. You lose the community of all the things that work specifically for the Jetsons configuration. And you're kind of on your own with an unsupported, an unsupported Linux, unsupported Ubuntu on one of these things. Now, it can work, but again, it's a lot of work to get there. And it takes, if you don't have a lot of deep generic Linux knowledge already, it's not something I would recommend to do. Another thing that is tough, and this is the thing that made me sad about trying to get ROS going, is that there's a lot of inconsistent documentation and maintenance, especially with what are called ROS packages that aren't part of like the ROS core packages. So a common thing that I've seen is that graduate students will create this paper and do this awesome thing, and they'll do it all in ROS, and then they graduate and move on with their lives, and then they don't maintain whatever it was that they created. And because what ends up happening is that it requires libraries that are deprecated and things just like you can't just expect it to work. And even if something is documented, you can't expect it to necessarily be right. It's a lot of going to forums. It's a lot of going to meetings like the one with Camp and saying, hey, I can't get this to work. And then getting ROS to work, it really becomes a hobby in itself. And again, the community is passionate, but it's niche. And so it's hard to find answers when things break, especially if you're not working with a standard, one of these standard out of the box systems where folks are doing a lot of folks doing exactly what you are. So it takes a lot of time and energy. And at the end of the day, it's not a time saver at the hobby level for 100% homebrew, at least for me. But the thing was, when I started with RoBud, I was really determined to use standards. I wanted to build this robot the right way. And I read some books on RAWs. I liked a lot about the way reading and learning about RAWs really helped me understand how folks had thought about, solving these problems of all these different systems working together to make a robot. And I said, look, if I'm going to build this thing, I need to do it to the standard. I need to do it the right way. And I was getting frustrated, and I was near giving up on the whole project. And I had a robotics buddy of mine who's a lot older than me. And he said to me, he said, the right way is the way that you can understand, implement, self-support, and ultimately make it work. And it was really an important thing. Probably the most important thing I learned with this project is I've worked in, when I'm working in software in a professional situation, usually it's as part of a large team that's backed by a large organization that you have to do things to super tight standards, and you have to do things according to best practices, but you always have a lot of support all around you to help to make sure that you can do that. And it's really different when you're a sole coder making a project on your own. If you're working on something that you don't understand and you can't support it. So, at first I was sort of feeling ashamed as, building things and not having it be a way that, that professional roboticists would respect. But, what professional roboticists don't respect is a robot that doesn't work or do anything. So I eventually got over that. And because the learning curve for me for RAWs was just too much for making it RoBud, I decided against using RAWs. And so that's kind of how I came to it. There were things, though, about RAWs that I really wanted to implement. And that same guy, he's a guy named James Newton. You guys may have had contact with him. I think he's a San Diego-based old school robot guy from the 70s and 80s. He was like, you know what? If you like certain things, just get them, take the ideas and roll your own. And so that's what I did. And so the first thing I want to talk about is the publish subscribe model, because that's one of the things that's core to RAWs and is really the thing that clicked the most to me. And when I read the books on RAWs and the publish subscribe model, all of a sudden it took the complexity of robots down to real small manageable chunks of code and hardware that, all had a very specific area of responsibility and communicated with each other through a messaging broker. And so what I did is there is a message broker that service called Mosquito that uses a protocol called MQTT. And MQTT was a simple messaging protocol designed for IoT devices, and it has worked great for me. So the idea of it is it's if you're familiar with how you do it with RAWs, it works very similarly, except it's simpler in that the message in RAWs, you'll have different kinds of strongly typed messages, essentially. And in MQTT, all messages are either strings or byte arrays. And you can convert things back and forth with that, no problem. It makes it really simple. So the idea is that you're just like with RAWs nodes, MQTT clients can run on separate threads, programs, or even machines over a simple TCP/IP. A client can publish a message to any topic, just like in RAWs, and a client can subscribe to any topic. So anytime a message is published to that topic, the client will get that topic's message and can decide to do something. And again, the idea is that allows each of the portions of your robot to have limited responsibility. And it have the portions of your robot has limited interdependence. So all these things can run separately, and it makes everything relatively simple at the module level of your robot. And as a guy working I work my day job and I have my 10-year-old. So I usually only have 1 or 2 nights a week for a couple hours to work on something. It also provides like manageable chunks of successfully getting things done for me to be able to, work on a new service or node that works with MQTT. So again, Mosquito is the name of the message broker service. You can get Mosquito at mosquito.org. One thing with Mosquito is because it's MQTT, it has 2 T's in Mosquito, unlike the regular English word that has 1 T. Paho is an MQTT client, and it is available for all kinds of different computer languages. I use the Python client. You can get that at eclipse.org/Paho, eclipse.org. The Eclipse organization is, they essentially maintain a lot of things around MQTT. I think it is a open source org that is connected to a bigger commercial endeavor, but it doesn't matter. These things are free, they're open source, and it works great. It's super fast, super duper easy to set up. And if for the Python client, you've got that right here. And so one thing I wanted, and then here are some examples of code you can get if you get this presentation. You'll be able to see the RoBud examples of code in the RoBud GitHub. I do apologize, it's kind of messy. There's a lot of stuff commented out because I tend to work, fast and loose with rules that I would keep more serious when I work professionally, but you should be able to follow what's going on. And so here is where I think I should be able to do the first demo of the night. So let me see if I can pull something up so I can just sort of explain to how I'm not going to go through the code, but I'll explain how this is utilized. So let me just change here. All right. And you should see a desktop. You guys see that right now?
Yes.
Okay, cool. So what I've got here is this application here is subscribing to RoBud's camera frames. And basically the way that this works, so if you remember, I said that when you're working with RAWs, there's an image type of message that you can set up. But with MQTT, you can, it all has to be byte streams. And so just fiddling around with this, what I was able to do is basically take each frame from the camera, use OpenCV to put some JPEG compression on it, and then convert that just to bytes, send it as a message, and then this subscribes to that message. And when it sees it, when it gets a frame message, it will use OpenCV to convert it back into something that can be displayed, and it's displayed right here. So let me show you some stuff too. I'm just going to stop the state manager so his head stops moving around autonomously. So then this guy down here publishes change. Let me put my password here. There we go. Okay, so this guy down here, this allows me to do keyboard control for teleop, and it publishes changes. So now you can see the video here, and let's go for a little trip around the workshop here. So in other news, this place looks pretty barren. I just got this space. It's a nice little 10 by 10 workshop space in a community wood and metal shop here where I'll be working on everything.
How are you driving that, Scott?
So I'll go over that in a little bit more detail, but basically all I'm doing is I'm using keyboard control. So my arrow keys to just, drive it around like it's a video game. And that's how it works. So, and again, the program that is driving this by using the keys is the program captures my keystrokes. And when I do the keystrokes, it publishes to the correct topics to tell RoBud's motors what to do. And servo. So I can move the servo, the head servo up and down. I can move it left and right. And if you see these eyeballs, I can also do animations here and change the expression of RoBud. And this program running right here is actually just subscribed to the same topic. This isn't a stream of what's showing on RoBud right now, but it's actually a separate program doing the same thing that happens on RoBud, but subscribing to the topic of how it should be displaying the eyes. And the same thing will be happening on RoBud as I do this. So just, you know, it just makes things really, really clean to be able to separate everything. And it's awesome. It just works. I remember the first time I did this, and I think it took me just like one night to get this camera thing going, and I was really happy with it. So in any case, that is MQTT and Mosquito message broker. So let me go back to Chrome here. But does anybody have any questions about publish subscribe with Mosquito and Paho? Okay, cool.
Actually, I had one question.
Yeah, go for it.
When you say you had to convert the binary data to bytes and then convert it back, that was a little confusing because isn't the binary data already in bytes?
Yes. So of course, yeah, and I'm sure that that's what happens on. I'm sure that that's what happens on RAWs, right? But I'm responsible for doing that rather than having something at a higher level that just abstracts that away from me, which is what happens in RAWs. Does that make sense?
Sort of. So you're basically just passing a void star on a size and it just gets those bytes copied over for you?
Yeah. Basically, essentially, I mean, it's really strings, right? So the messages are all strings, and I pass the strings in. You can look at the code, but I can't remember exactly how I did it. If I convert it to a byte, or if I take the JPEG image and convert it to a byte array, I forget exactly what the details were. But on both ends, I had to run code to turn that byte array, put that back through OpenCV, turn that into an image and display it.
Okay,
Going
gotcha.
back-
So it's a string object, not a char star.
Well, Paho
Yes.
is a Python library, right? So Python makes a distinction between strings, which are Unicode, and byte arrays, which are what you would expect byte arrays. But I imagine
Yes.
what's going on is you have to pack to get into the wire endianness and all that kind of stuff.
Yep, exactly. And actually, an easier, a simpler way to do it, it might not have been efficient because I didn't really play with it as much. But if you're using Python, you can use the pickle library, which is the serialization library that is used in Python. And you can take any Python object and serialize it and then deserialize it on the other side. And I actually do that for more complex objects down the line. So I can get a full object with properties and methods and all that jazz pass through, and it works fine, and it's nice and fast.
Scott, I didn't get what version of Ubuntu you're using.
Oh, sure. So for the Jetson Nano, there's the development libraries are published by NVIDIA in what they call the Jetpack. And each version of Jetpack comes with a NVIDIA flavor of Ubuntu on it. So the Jetson Nano uses a version of Ubuntu that is equivalent to 18 dot, what is it, 18.01 or whatever. So it's a little bit of an older version of Ubuntu, and it also uses Python 3.6, which is a bit of a pain because that's, I believe, if it's not out of support, it's about to be. But that's another. I didn't want to get too into the pains of using the pains of using the Jetson Nano. If I started now, I might go with a Raspberry Pi and maybe a Coral USB stick, or just use a one of the really nice OpenCV cameras that are out there. However, that's my spiel on that. I don't want to. That's off topic. Any other questions about MQTT publish subscribe model? Okay, cool. I appreciate your all's engagement in this. So the next thing I want to talk about was doing animated displays and keyboard control, both handled by a neat library called Pygame. Now, if you have a Raspberry Pi, Pygame comes pre-installed, so you're already halfway there. You can get it at pygame.org. That's also where the documentation is for it. One downside of Pygame is it uses X windows. It's so Pygame as a library, it's designed to make essentially 2D sprite video games in Python, sort of like what you would play on maybe like a Super Nintendo, that kind of, or side-scrolling game like Super Mario Brothers. And it's pretty advanced, so it's all designed to animate things on the screen fast, move them around, have animated things as objects, and also to take controller input. So you can even hook up, you see that this guy has a remote, has a video game controller in its mouth. You can hook up controllers. You can also do really nice things with keyboard control. So for RoBud examples of this, you can see the animated face. As I said before, it's messy, and then the keyboard control. And so if we go back to here, this guy right here is a Pygame window, and as long as I have it in focus, that's when it's capturing the keyboard information it's capturing the keyboard information and then sending the messages. And then if you look on the right side, I'm using Pygame to do these actual animations here. And I was really happy with the way they came out. It's nice and smooth. And it was, again, just a couple nights of work.
We're only seeing that one picture of the Pygame.
Oh, you know what? I'm sorry. Let me switch here. Yep. So that's here. Again, so here you can see the RoBud's animation. So here's his basic eyes. Then we can be happy, we can be ecstatic, we can be bored or annoyed, we can be angry, and we can be skeptical. And I really, it's really nice and easy to set this up. So let me go back to the Chrome window here. So here's where you can get it. There's I think one more bonus. So if you want to have smooth animations, so generally if you're animating and you want something to move, some eyes to move or an animation to happen, you want something to move from point A to point B, you do the math and it will linearly move across the screen. But if you want to get a little bit of, Disney whim to what you're doing, there's this great library called PyTweening. Let me go back. And what that does,
Scott,
go ahead.
Quick question. RoBud's computers NVIDIA, right? Nano?
Yep, it is.
Okay, are you running this Pygame on the NVIDIA Nano?
Pygame is running on the NVIDIA Jetson Nano, yes.
Oh, okay.
It doesn't use the GPU though. It only runs on the CPU. But it also comes installed by default on Raspberry Pi, so it's even easier to get to work, and it should work on any Linux environment. And again, you can get these smooth animations with Pi tuning. If you've ever worked with like HTML5 animations, there's this idea of easing in and easing out your animations and different things you can do with that so that it's not, the animations aren't so linear. Give them a little bounce, whatever, give them a little weight. You can do that with a Pi tuning line. Any other questions about Pygame?
I was just gonna say it runs under Windows. I use it for Orange's Eyes and Control Panel, so it's cross-platform.
Jim DiNugio.
Yeah.
Thanks, Jim. Love Big Orange.
It works on Ubuntu 20 on
Mhm.
the Raspberry Pi.
Awesome. Any other Pygame questions? All right. So making RoBud, hear and understand. So this was kind of months of work of trying different technologies and stacking these together. So the first thing that I use is what's called a seed respeaker V2 4-mic array. I know that Big Orange uses this as well. Let me see if I can click on this and show it to you. Okay, cool. So here it is from Seed Studio. These guys are great. And what this basically does is it's a directional microphone that has built-in algorithms for automatic voice detection as well as filtering out noise and that kind of thing. It's basically, it's designed if you wanted to build your own Alexa, this is a microphone that can handle that. And it can also handle knowing which direction you're calling from. I know that if you're on the mailing list, and I think on the in the verbal intelligence group, Jim showed off his Big Orange where he would say something out loud and the robot would actually turn towards the sound. It's because it uses this same technology and it's great. I don't have RoBud automatically turning yet, but I plan to be able to do that. Once you have the sound coming in, you need a way to process it and react to it and do things with it. So I use the Pi Audio Python library. And so what I'm doing is I take the sound that's coming in from the mic and I use the Pi Audio Python library to take those chunks of audio and publish them to topics just like everything else so that it can, other services and nodes can subscribe to the audio channel and decide what they want to do with it. One thing with Pi Audio that I do want to state in working with audio, I've always sort of took it for granted, and it's a bit of a learning curve to get going because getting Pi Audio to work with the hardware and then also in near real time and dealing with that, especially in Python, it was a lot lower level than I expected. I'm used to working with things like DirectX where that was just available. And it gave me a deeper respect for anybody who, works with digital audio stuff. So if you're working with Pi Audio, that's another one where it's not quite as difficult as RAWs, but don't expect it to work the first night you sit down and work with it. It's going to take some tinkering. It did it, at least for me. So one thing with RoBud is I wanted to be able to be, similar to Alexa. You want to be able to say RoBud's name and then have it listen to you and then be able to understand what you're saying. And whoops, did I lose you guys?
We can hear you.
Okay, cool. And you can still see the picture?
Can still see we still see the one slide.
Okay, I can
Or-
see it looks like I'm the Zoom is trying to reconnect me right now. Oh, I see my computer just lost internet connection. So what I'm gonna do is reconnect to that, and somebody, if you want, you can. Can you entertain everybody for 30 seconds, 1 minute? Did I lose everyone?
No, we're still here.
Ken was
Okay,
telling a
cool.
joke with his mic muted.
Oh, okay, that sounds
We
good.
can hear you fine.
Alright. Great. Yeah, let me just go in here. The space that I'm at, one downside of it is it doesn't have any internet, so I'm using my phone as a hotspot for this. And it's working great, but it just crashed, I think.
Technology is great when it works.
Oh yeah. Please. That's iPhone. Connect, please.
So, hey, I don't want to distract you, Scott, but I really don't know where you get the RAWs with the Z.
Really, you haven't heard it called
I'm
Ross?
gonna call that a Chicago dialect.
Yeah, I guess. I mean, it's just not. It's not Ross, right? I would have called it Ross.
I always say Ross.
Really?
System starts with an S, not a Z.
Yeah, I've heard people say Ross before. I don't know. I'm just trying to, like I said, I was just trying to be like the cool kids. Maybe I was trying to be too cool.
Henceforth, I'm going to consider that the Chicago pronunciation.
Oh, sure. Yeah, that's the way we say it here in Chicago. That's exactly it.
I can show a pie game demo while you guys are waiting.
Entertain us, gentlemen.
Yeah, go for it.
I think James Bruton pronounces it that way too.
Maybe that's what it is. From watching James. Yes, he totally does. Yeah, it's from watching his videos talking about it.
I'm a fan of his.
Oh, how can you not be if you're a robot fan?
Guys getting
He's
pie
great.
games.
Very nice.
Yeah.
He put one of my robots in one of his videos last year. Yay!
Very cool.
We're hard to impress, but easily amused.
He was amused.
Yeah, pie games is pretty easy to use, actually.
Oh, look at that. That's cute.
Yeah.
The idea with this is they're gonna hopefully attach it to a face tracking. So actually get the eyes to move to the left and to the right. So it sort of gives the impression that the robot actually knows where a person is.
Yeah, this is Jim. I did that. I'm doing that with Orange, and when the robot turns to the left and right, it can also, basically when the top camera turns on its pan tilt, then the eyes move.
And then I also wanted to do a motion detect, but in ROS, all the motion detect is written for depth cameras. So it's not just.
That sounds pretty cool, Jim.
Yeah, well, mine is that, I have a depth camera, the Oak D. That Oak D is like the best thing I've ever bought for a robot, or in my short history of robotics, but that thing, the Oak D camera, does so many things. But yeah, Pi Game is really good to help out with the UI. Although it's not like HTML based, which a lot of people are moving towards for any kind of UI will work on your phone as well as other places. But you could run Pi Game on a phone, I imagine, too. I don't know.
Yeah. Well, the idea is that's the output, and what the input is some AI that's doing people tracking or face detection or interact. So it's the opposite of the intelligent speech. It's emotion detection and eye detect, nonverbal communication.
Yeah, it's neat.
Speaking of verbal communication, I'm back up.
Okay.
There's this one, and then there's like a star type of thing. Oh, but it doesn't have the paper thing. I can show you if you want to see.
Oh, is it those first?
What's that, Dee Dee?
Dee Dee, you're on.
Oh,
You're on
sorry.
the air.
You got a hot mic, Dee Dee. That means you're
All right, Cam, you want to re-spotlight me? All right, cool. So sorry about that. Thanks for your patience. So we've got how RoBud is hearing, but how do we get RoBud to understand? And one of the, there are a lot of cool text to speech to text solutions that are out there, but they're all very expensive processor wise, right? It's doing a lot of audio processing, and you don't want your bot, at least with my single board computer, I don't want the CPU or even the GPU spending all its time trying to transcribe everything it hears. And this is the way a lot of the home assistant speakers work as well, is that they're not always transcribing what you say. They're waiting for a special trigger that is called a wake word. And the way the wake words work for most assistants these days is that there's some kind of inference basically an inference neural net model that is really, really small, designed just to hear one specific thing. In fact, that's why Alexa has a 3-syllable name that is very specific sounding, is because it responds so well to the wake word. So there is a free wake word library from an open source assistant company called Mycroft. These guys, they're great. They're basically trying to build an open source Alexa, and they're pretty much mostly the way there. And but they make all the stuff that they build available to everyone. It's real modular. So you can do what I did, is take the Mycroft wake word engine, which is called Precise, and then integrate it into your system without any of the other Mycroft stuff. It's fully offline, so nothing's being sent out over the internet. You can get it, here's the GitHub link for it, and then you can see an example of how RoBud uses it. And then once the wake word goes, we want RoBud to be able to take what we say and transcribe that to text so that it understands it. And for that, I know that some people use Vosk, and I think we're going to get a presentation in the verbal intelligence group on Vosk eventually. But one problem with Vosk is, well, I know it works on the Raspberry Pi. No one's gotten it to really work on the Nano. So what I'm using is a library called Koki STT. It's from a company called Koki, but again, everything's all open source. And originally it was a team working for Mozilla, and it was called Mozilla Deep Speech, but the Mozilla org ended that project. So the folks left and started their own thing called Koki STT and have been building on top of it since then. Here is the GitHub for it. And here is the example of how it's used. And let me show you, now that I've kind of gone through all this, I just want to show, the basics of how RoBud does some of this stuff. So quick demo here. Let me pull up RoBud here. And I'm going to move my headphones away from myself and talk to RoBud. I won't be able to hear you, but I'm going to put the mic close to RoBud so that you can hear him. So before you ask me anything, go ahead, Cam.
Is it live?
This is live, yeah. So we know how those go, right? But we'll see how it works, all right? So, but just again, I'm going to put the microphone down. I won't be able to hear you for while RoBud's talking, and I'll pick it back up. So just give me about 30 seconds before, if you have anything to say or ask any questions. So here we go. Just put in the microphone. Just gonna drop it right down by the speaker here so that you all can hear it. All right, so one thing, you can train the wake word to be whatever you want. Eventually I want it to be, hey, RoBud. But right now it is the default, which is Mycroft. So I can say, hey, Mycroft. Hey, Mycroft. Oh, I know it's wrong here. 1 second. I just have to turn RoBud's state manager engine back on so he listens. 1 moment.
What's that wake word again, Scott?
It's the name of it called Mycroft.
All right.
It's the name of the software.
See if he starts moving around. Hey, Mycroft. Hey, Mycroft. Oh, of course. You know how live demos go. All right, I'm gonna give it one more shot.
Gotta love it.
Hey, Mycroft. All right, I got these back on. Yeah, I got hit by live demoitis. I was totally overconfident here. I'm gonna check one last thing because sometimes the audio engine crashes.
It works so well when you were preparing, right?
Oh, I did it a bunch of times. I mean, Al can attest to it because I tested it with him and he was listening.
You got a video?
No, just give me 1 second here and let's see if I can get it to work. If not, we'll move on. The technology is good. The implementation of it is, not working is probably my fault. So let me just look at, so one thing I let's take a look at my services here, and I can actually, this might be useful for folks. So one thing is I'm using system D services for all of the equivalent of the nodes that you would have in ROS. So if I go to, I'm just gonna list my units here.
Hey, Scott, you
yes?
might want to reshare this window with the video optimization turned off because the text is a bit, it's not legible.
Oh, I'm sorry about that. Yeah.
There's a button, there's a checkbox. I don't know if you have that on or
you can also,
don't.
you can also increase the size of the font. That would make it more legible.
Okay, I understand you guys can't read this. Just give me a second. Let me just run this command line then. Yeah. Well, you know what? I don't know why it's not working. I do have a fan running in the background. I'm going to shut the fan off and try it one more time, and then we'll just move on. Hey, Mycroft. Hey, Mycroft. Unbelievable. He should be moving around right now. Maybe I didn't get the
Murphy strikes again.
Yeah, of course. It's crazy because I really tried to make sure I was going to run into that problem.
Sorry,
oh well.
I can't do that, Dave.
Yeah, exactly. Well, next time I'll show you guys. We'll do it during the show and tell, and I'll make sure I get it to work. And because I'll make a video of it and show you the video. All right, so sorry about that. Let's move on to the next thing. Let me switch back to my view of the presentation.
Scott, was the Mycroft going through the same Mosquito publish and subscribe, or is it a separate system?
It is, yeah. So what I have is I've got a wake word service that I created, and it's all it does is it's got Mycroft. It's a Python script that runs in the background and just listens for that wake word. And as soon as it hears the wake word, it publishes that the wake word was heard. And then the other services react by subscribing to that. Does that make sense?
Yeah.
All right, so making RoBud speak. I use technology so one of the important things with RoBud as part of it being.
Interrupt you, but I want to go back to the other thing. When it was listening, and you were saying that it would be moving. Are you telling it to go forward, left, right, or is this just programmed motions for RoBud?
So when I said it wasn't moving, so basically I have another service that's called the RoBud State Manager. And it's a state machine that moves RoBud from different states. And right now RoBud has a default state where it just kind of goes into a demo mode and starts to look around. But then if it hears the wake word, it will switch into a different state. And since RoBud's not moving around right now, it means that he's not correctly in his idle state for some reason. And that's probably why the wake word isn't working, because RoBud's just sort of sitting there doing nothing. And actually, I have a feeling that maybe it was because I might have lost connection to the hotspot on my phone when things went down. So could be related to that. But does that answer your question, Camp?
So that when you gave it the wake word and it went into the idle state, would you give it commands then to move, or is this more like a chat bot at this point?
Oh, it's a chat bot at this point. Basically, what I was going to show is I would have woken it up and asked a question, and then it would transcribe the text that I say. It would send the question out to the Wolfram Alpha API, and then it will give me the answer back in audio.
Thank you.
Making RoBud actually speak. So it's probably, if you folks have been working with Linux for a long time, Unix for a long time, you might be familiar with the eSpeak, the speech synthesis program. It's been around for a million years. It was no longer maintained by the original author. So the currently maintained fork of eSpeak is eSpeak NG. You can get it here, and it's really simple. It allows your robot to talk. It's fairly understandable. And the thing that I like about eSpeak is that it is really inexpensive CPU-wise. So a lot of stuff that if you want your bot to have a beautiful voice, you can use external services like I know that there's a great one through Google that will generate like gorgeous speech for you. But one of the things that I really wanted to do with RoBud is make sure that everything worked on board RoBud. So I wasn't depending on any external APIs that could eventually go away. And then what I do is to give RoBud a unique voice, which I wish you could hear, but I also use the Librosa audio processing engine to modify the voice to get RoBud to sound exactly the way that I want it to. And that is available at librosa.org. And then here's, you've got examples of, this is actually the same example here, and it shows how RoBud's voice is generated. And what I'll do once we get through all this, I'll see if I can get RoBud to say anything. But I might need to play around with it a bit. But I want to just make sure we get to everything here, because here's one of my favorite things, is I feel like this is a treasure discovery. So this is what I call, we need more power, Captain. And I've seen in the newsletter, not the newsletter, I'm sorry, in the email list, that folks have been asking power questions. And one of the biggest problems I had with RoBud from the beginning was I just couldn't get enough power out of the phone charger bricks that were around. And I didn't want to use straight lipos because I want this thing to be something that folks, it's really easy to build for folks. And I don't want them to worry about, burning their house down by overcharging their lipos, that kind of thing. So I really wanted a consumer product that just delivered the power and handled all the safety issues, and that essentially just worked. And I finally found it with this thing. So it's called the Basis 65-watt power bank. It's available here from Amazon. And the greatest thing is that it's got two USB A outputs that you can get 30 watts from. And then it's got a Type C that USB-C that can take 65 watts in or out. And so what I use this for, though, is I've got the Jetson, which is a super power hog and is super finicky about any voltage drops running off one of these USB A. And then I've got the display running off another one of the USB A. And then I've got RoBud's locomotion motors running off of the USB-C. But these two are both at 5 volts, but this runs at 20 volts, which is the super cool thing. So if you, a USB-C standard has this standard called power delivery. And rather than having to use something like a buck converter to change between, to go down from a higher voltage to a lower voltage manually, you can abstract that all away with USB-C. It does it with USB-C power delivery. The idea is that you'll plug something into USB-C, and then they do a little handshake with each other digitally and decide what level of voltage is going to be shared and which direction it's going to be sent. And there are these little super cheap 12 volt or 20 volt trigger modules that are just hardware modules with a little chip that will do that handshake and will just say, send this to me, send me 12 volts, send me 20 volts. And so I have these little triggers from Amazon hooked up and plugged connected with a USB-C cable to this power brick, so that the power brick will output 12 volts for my motors and 5 volts for everything else that I use. And I'm telling you, it works great. It's like, I've had this on the whole time, and we've gone from 99% full to 88% full. All this time that I've just had the RoBot sitting here and doing things with it. So I love this thing. If you want an easy power solution, I recommend it. It's like $60. All right.
You know what the milliamp hours are on it as far as capacity?
Yeah. It's let me open it for you. I mean, it's 20,000 milliamp hours.
Okay, and the size of it, is it bigger than a pack of cigarettes, or?
It is bigger than a pack of cigarettes. It's like a pack of cigarettes and a half stacked on top of each other. It's long and about an inch thick.
But not that, yeah, it's not a big brick, not a big thick brick. It's kind of a medium.
Yeah. Let me show you. Let me switch back to my RoBud view here, and you can kind of see it. I've got it in here. This is it plugged in right here, and it's it goes from about here to here on RoBud. And it works. It's like I say, it's bigger than the other smaller power bricks that I use, but it gets the job done. It's got some heft to it. It's got some weight. So I wouldn't want to hook up, a couple 6-volt motors to it, it will have a hard time just moving it because of the weight of it, but it's worked great for what I have so far here. And so those are the things I wanted to show about RoBud tonight. This is for Q&A. If anybody has any questions about the stuff I showed, or any questions about RoBud or anything, I just feel real lucky to be able to show this to you all. And I hope that, you know, some of it is useful to someone who's gonna put something in their own robot.
About how many hours do you have into RoBud?
Oh, I haven't tracked. You know, I've been working on it for about probably 16 months, and probably put in, you know, 5 to 10 hours a week. I don't even want to know. You know, so it's not thousands of hours, but it's hundreds.
Right.
We have a question from the RoboNexus here from Dan.
Are you running ROS 2 or ROS 3? And what are your thoughts about the difference?
Well, one, I'm not running ROS at all. And do you mean ROS 1 versus ROS 2?
Yeah, that's what I meant.
Okay. Well, I'm not running ROS at all, so I can't really answer that. However, if I were going to, I originally was trying to run ROS 1 with RoBud because of the better availability of all different packages for it. However, in the past year since I started, the adoption of ROS 2 has come a long way. And I think really that question is best answered by someone like Camp or joining the ROS SIG calls every Tuesday.
So in that respect, Scott, you know, right now you've got the lovable companion, you know, talking and that sort of thing. I mean, do you see getting into mapping and navigating? You got a camera on there.
Yes, absolutely. So one of the things that I think the idea I want RoBud, I have a little dog that is about the same size as RoBud. In fact, RoBud's got a little bit more weight than my tiny little dog. So that dog is sort of the inspiration. And what the idea of having RoBud be also a cross between a dog and a baby is sort of like RoBud's not necessarily going to have great object permanence. It doesn't have to. So RoBud's more going to be more trying to move around. Like the idea is RoBud will pick a target and try to move towards it, whether it can hear it or see it. And if it kind of thinks it's somewhere, it hears it, it's going to try to go around things and get to where it's going to go. But I don't have major plans to do full slam with RoBud because I think it's probably overkill for what I initially want to get to, but I'm very interested in the concept of it. So eventually maybe I just have a bunch of other, you know, other difficult problems to that I want to solve first to get RoBud to really be moving around on its own. But it's going to be more of seeing something it's interested in and moving towards it and then getting around obstacles to get towards its goal and then choosing a new goal rather than localizing itself within a complex space, if that makes
like
sense.
Vector, it's an electromechanical creature.
That's right.
I was interested in the mosquito and the MQTT stuff, and it seems I haven't used that, and it sounds like a good alternative if you're not using ROS. I mean, in ROS 1 or original ROS, you had had the hub, or I forget what's it called. You had to run the ROS node or the ROS hub.
ROS core, right?
ROS core.
Master.
ROS core was kind of a broker, right? In this case, the mosquito is this broker that handles, is the middleman, right? And it handles the acceptance and then delivery of the messages. Is that right?
That's exactly right. And that was exactly my thought process is when I wanted to use ROS, one of the main reasons that I wanted to use it was I really liked the publish subscribe model of how everything was done. And so when I was struggling with ROS, but then discovered Mosquito, I was really happy with the way it worked. And I used it as an alternative. Yes.
And the other side, so that's, yeah, Mosquito. And then the client side is what was the client side called?
The client is called Paho.
That's it.
Yeah, if you search, so there's the organization that is super into it and maintains Paho and also does a lot that also makes Mosquito is called Eclipse. So if you go to eclipse.org, you'll find both Mosquito and Paho. And Paho is not just a Python library, but it's they've got Java client, they've got C# client. Eclipse is really trying to push MQTT as a standard, I think, for commercial IoT. And so there's a lot of weight behind it, but it's great because they truly open source everything too. So it makes it, it's really nice to be able to use.
Yeah, that's cool. Good info.
Any other questions? All right, one thing that I'd like to do here is, if everybody's okay, is I'm going to try to give RoBud a reboot to try to see if we can get it to talk one more time.
I'd like to thank you for showing us RoBud, Scott, and give you a big HPRC round of applause.
Oh, thank you so much, Kent. Thanks, everybody.
If anybody can appreciate demos going awry, it is this group. We have all been there. Now, this is a great project and I like it. It reminds me of like the David Heiserman and the How to Build Your Own Self-Programming Robot, where, you know, he was talking about it in terms of being a creature. And I've heard this espoused by other home brewers is, you know, they don't like the term artificial intelligence. It's just a, you know, it's real intelligence. It's not artificial, but it's not human intelligence either. It's something different. And so it looks like you've got a vehicle for getting there with RoBud.
Yeah, thank you. Yeah, and you know, one thing I'm very interested in is human robot interaction on an emotional level, and our human tendency to ascribe feelings and ascribe, like if you, it's not just with robots, but just like if you look at like Kermit the Frog, right? And that's just like Kermit the Frog's eyes don't move. All it is a guy with his hand on the mouth. But you eventually, you see this performance and you get a real, you know, emotional reaction. And so that's really kind of what I'm interested in with RoBud, but at the same way Kermit the Frog, everyone sees it and knows it's not real. I want folks who interact with RoBud to be the same way, right? And not ascribe too much intelligence. So you don't get the extreme situation like you did with that guy who worked for Google's GTP3 and started saying, yeah, exactly. And started saying that, you know, this autocomplete bot was sentient because of his human tendency to be tricked into it. And I think that that's a real ethical dilemma, not the dilemma that we thought we'd run into from science fiction of robots gaining sentience and not having rights, but people thinking that robots are real emotional sentient things because of our tendency.
Mobile robots are to other appliances what animals are to plants. I
Yeah.
can't think of anything else that people name around their house besides their Roomba or their Nido. They name their cars, but you don't name the appliances because they're analogous to plant. They're, compared to mobile robots. So people anthropomorphize.
Right.
Yeah, there was a great discussion on the news, on the mailing list about this, and how humans, we have evolved to the higher level cognitive function has evolved as social animals in the primate branch to very easily ascribe emotions and thought to something with a face and a head, and it looks basically human or animal even. And so
Yeah,
part
we
of our
have
evolution, I guess.
We have circuits in our brain that react specifically to faces and things that look like faces.
Right, so it's very different from animals, although like dogs are very well bred and trained or to understand human face and gestures, whereas a chimpanzee, which is arguably objectively a lot more sophisticated brain and intelligent, it can't follow a human. When you're pointing at something, it won't find the food, So
This is why we put googly eyes on our robots, right?
yeah, and just putting eyes alone made a huge difference when I put eyes on. I didn't expect it to do that much, but
One of the funniest was Maker Faire. Dan with the Karen, not Karen, but the Watson that was leaning against the pole, and nobody was noticing it. It was like a ladder, and then he blew up a balloon and drew a face on it, and all of a sudden everybody started noticing this robot.
Yeah, it makes a big difference. Hey, everybody, I just got it talking. So do you want to see if it worked now just a second ago? Want to see if the demoitis hits now that you're all looking?
Go for
it. Let's see. Okay, I'm gonna switch my headphone again. Hey, Mycroft. I love you. Almost. Hey, Mycroft. Yes. I love you. I don't know. Oh well, get in there.
That's awesome.
So, yeah, at least you heard the wake word, wake up, and normally it responds with affection, but I think RoBud's just being shy right now.
That's hilarious.
Yeah. The wake word is kind of cool. I haven't, I kind of experimented a little with that technology, but not the one you're using. It sounds like it turned out pretty relatively straightforward to put in, was it? And it not too difficult to integrate with your other stuff.
Yeah, it was really easy. And the next thing I need to do is do training, which I've talked to other folks who've done the training, and it's got a built-in training command line app, and folks have been pretty successful with it. And in fact, I was thinking of writing to this group because I don't want the model to be totally fit to my voice. So I'm gonna do Hey RoBud with my voice and my daughter's and my wife's, but I'll probably reach out to the mailing list and see if folks can provide me with, their voices saying Hey RoBud, so that I can, train it as widely as possible for anyone who wants to participate in that.
Scott, you mentioned that in the future you want to swap the Nano with the Pi and with the Coral accelerator. can you do the same thing with talker and listener or publisher? And
Yes. Yeah,
with-
absolutely.
with a Coral?
Well, I don't want to use, I don't have any experience with the Coral dev boards. And I know the Coral dev boards have their own Linux-like operating system, and I just don't really know anything about it. So what my plan would be to use a Raspberry Pi 4, which all the stuff we showed tonight will work on the Raspberry Pi 4, except the computer vision stuff that I didn't show tonight isn't going to work well on that without a Coral dev board for inferencing. One thing, this is a long-term plan for me, but what I really want RoBud eventually to be able to do is, come up to me and, for example, say, look at my face, remember it and say, who are you? And then take pictures of me and remember who I am by seeing me. And then remember who my wife is, remember who my daughter is, basically recognizing its own family. And I also had an idea where it would be able to it would see you in the kitchen and I would say, he'd go, what you doing? Like a 2-year-old. And I say, I'm cooking. And then RoBud would say, you are cooking? I'll remember you're cooking. And then see someone else in the kitchen and infer, are you cooking? That kind of thing. And to do that in theory is possible by using what's called transfer learning for the neural network models. You can do it on top of the object recognition models and the image recognition models, that kind of thing. But traditionally for retraining like that, you have to do it on a PC or something bigger than your single board computer. It just is not going to be able to run on a CPU. It needs a GPU to run. In theory, you can do that with the Jetson Nano, but I also saw that with the Coral, it has built-in techniques for on-system training for transfer learning like that, where it's basically, when I say transfer learning, it's taking the last layer of the neural network and just retraining that last layer with the classes that you want it to see. And so, sorry, I'm kind of rambling there, but basically that would be the idea.
Well, Scott, one added bonus if you're using the Python, if you're using the Raspberry Pi, is that you can run Ubuntu 20.04 and ROS2 on it and use all the new packages that are available on Ubuntu 20.04.
Yeah, actually, so for there is you can run ROS2 with an NVIDIA. There's somebody, I know someone in our group, I forget the name of who it was, actually built a bot called what's that?
Ross with 2 S's.
Ross
Out
is-
of-
the
Okay.
Nanosaur,
Right, the Nanosaur, exactly. And the way that works is it runs in Ubuntu, it runs ROS in an Ubuntu container, a Docker container.
Right.
And you can do the same thing with the Raspberry Pi. My concern with installing ROS natively on a Raspberry Pi is that if you blow away the Raspberry Pi OS, you're losing a whole bunch of stuff that Raspberry Pi installed there to make your life easier with that specific board and all the community using it. All of a sudden you're taking this amazing Raspberry Pi and just turning it into a generic Linux Ubuntu computer, which is fine if that's what you want. But if I did it with Raspberry Pi, I probably would try to do the same thing if I did ROS and have it be in a Docker container so that I could keep the Raspberry, it used to be called Raspbian, but it's now called Raspberry Pi OS, so I could keep that on there and get the full support of Raspberry Pi as a company, which is much better for makers than NVIDIA is with the Jetson.
Hey.
And that's, go ahead.
No, I was just gonna ask before we get away, can I get a glamour shot with you and RoBud?
Oh, sure. Here, let's just come on down.
I don't see.
to get you all over the floor.
All right,
You gotta go
hold
lower.
on, hold on. Yeah, maybe. Here,
Just pick it
we'll
up.
do it. Well, yeah, we'll do it this way. We'll do it this way. Let's switch to, yeah, we'll do that. I'll switch to my laptop cam, and then I'll pick up RoBud, and we can just be right here.
What kind of motors are you using for that bot?
I have a couple of 12-volt motors that I got from
Thank you.
Amazon.
Are you using encoders?
No
to do your-
encoders. Yeah. So I don't. I do all my odometry type stuff with just figuring out. I don't do detailed odometry. I have a BN 055 orientation module from Adafruit, which is a great fusion module that fuses gyroscope, magnetometer, and all that, and just to figure out so I can always get its heading, which is sort of how I do most of that stuff right now. And I also have a time of flight sensor that I'm using for object avoidance right now, and just telling when something's in front of it. And I don't know whether I still haven't done a lot of the autonomous moving around the house stuff. I think I'm gonna also put some sonar arrays on it just to keep it from bumping into things on the sides.
Just as obstacle avoidance.
Yep.
Very, very, very nice. Very interesting. Congratulations.
Oh, thank you very much. It's been a lot of fun.
Very good. I like it.
Awesome. Well,
Great work.
thanks a lot. All right, Cam, I'll pass back to you.
Thank you very much. Thus concludes our meeting this evening. Scott, well, thank you very much for your work there. The meeting's hereby over. And we're into random access now, where we just hang out until the security guards come and throw us out. Thank you very much.
Enjoyed it very much, Scott.
Oh, thank you so much. It's been, it's really, really nice to have found you all as a group, to have somebody to share this stuff with, because before that it was just me messing around and thinking I'm a crazy person all by myself.
RoBud looked annoyed there.
Yeah, that's his skeptical look. He doesn't like the glamour shot. But isn't that's the thing that I like? It's great, right? So those expressions, of course, are just randomly generated, right? However, I had with the Shy Bots, a Chicago Robots group, we did a thing at a library for kids, and there was a woman who worked at the library who really liked RoBud, and I think she was an intern. She was like a senior in high school or something like that. And she was like really interested. So she got really into teleoperating RoBud, including I showed her how to publish messages to make RoBud speak, because you can do that from the command line. And then all these like first, second, third, fourth grade girls came in and started talking to RoBud. And then you had the puppet master, you controlling it in the background, but she had just sat down and learned what RoBud was the first time. And there was laughing and giggling, and it was really awesome. And it's just like the magic of making a robot have emotional connections, it's really comes from the people, not necessarily from like having some kind of perfect software. You trigger the people to enjoy it, have fun. So